From the previous video, we are good with the use cases and the problem statement that Kafka is solving. So it's time we see the introduction to Kafka. What is Kafka? Kafka is an open source distributed streaming platform which is designed to handle high throughput real-time data feeds. Open source means it is free to use. You don't have to pay anything to anyone. You just have to set up it on local machine and the learning curve is there and you're just good to go with that. Distributed means it is not a single machine. When you push something into Kafka system, it is replicated through multiple machines so that one machine, one node fails, your data is safe with other machines. So you will, it is fault tolerant, it is resilient to failures, that because of this distributed architecture. And we are able to handle huge volume of data because of this distributed architecture. Streaming platform means like when we see usual messaging system, messaging platform and streaming platform, timing is a critical factor. When we push something into Kafka, how soon it is available to other systems for processing and how soon it is processed data is available, that is the boundary line between streaming and messaging platform. And this system is designed to handle high throughput real-time data feeds. High throughput means a huge volume of data can be processed in a least amount of time with this one. Real-time data feeds that we just talked about, it is available very soon to the processors, to the consumers and to the end users. If we talk about the history of like how it came into picture, so it was originally developed by LinkedIn. We all know the LinkedIn, the professional website. So they had their own use case of messaging, sending the notification and asynchronous use cases. So they were using the tools that were available there. So might be that RabbitMQ or ActiveMQ, but that was not meeting their requirement of the throughput and large amount of data processing that they needed. So they tweaked the existing architecture of the messaging system and built something in-house, and that is what they built is known as came to known as a Kafka. It was originally developed by LinkedIn and it is now maintained by Apache Software Foundation under open source licensing. So anyone is free, anyone can use this setup and go download setup and just use it. At its core, Kafka is still distributed pub-sub messaging system. Pub-sub messaging system is publisher and subscriber messaging system. So take an example of like YouTube. So when you go to any channel, if it interests you and you want to see the future content of this one, you go ahead and subscribe that one. And anytime that new content is available on that channel, you get notification for that. You get recommendation of that in your profile or when you open the YouTube, right? So you subscribe that channel and creator of the content is publishing the content into that YouTube channel. So that YouTube channel, you can say that it is a category that same like-minded persons are there, like someone is creating and someone is consuming that one. So the next line that goes like it allows producers to publish messages to a set of topics. Topics you can consider as an example of like category or a bucket or a YouTube channel itself. That can be a topic. And consumers to subscribe to those topics and receive the messages, right? So if I talk about in Kafka, like different systems, different services are pushing the messages in a particular topic, and that topic is subscribed by interested consumers who needs to process that data. Whenever the data is available on that topic, consumers get that data and they process that data accordingly. So that is how it is like at its core, at its basic level, it is a pub-sub messaging system. On top of this, we tweak it. That is how we call it like streaming platform, real-time data feeder, other names we also. That is about configuration that we do with this. But at its core, it's a messaging system like others, RabbitMQ, Kafka, RabbitMQ and ActiveMQ. Coming to the next point, Kafka's unique architecture and design make it well suited for handling large amount of data in real time, which makes it a popular choice for all these data processing, event streaming, real-time analytics. So whenever we have requirement of processing the data, there is two things. First thing is like we want to process huge amount of data in least amount of time. Another one is like I need to process the data as soon as possible. So data is not that much huge, but I want to process it in least possible time. Both of these things cannot go together, so one thing we have to compromise on that. So when we have to process huge amount of data, we just have to compromise on the latency part, and when we have to process the data in the least amount of time, we have to like compromise on the throughput part, like in a short span of time how much that data it can process. Another requirements can be like when we have application like banking, where the data is critical and we are not ready to lose a single data, and we need that data. So for that also Kafka can be configured. Other requirement is like analytics purpose, like we want to analyze the user behavior who are visiting our website. Based on that, I want to recommend them new products. On that analysis part, if some of the data, like for a second, for a minute, for our data is not there, that is also fine. Our recommendation engine is not going to perform that bad if we are lost. So the data loss is allowed or not is also a requirement that can be configured with the Kafka. So its unique architecture has left the configuration up to the users of the Kafka, like the softwares that are using this Kafka, to tweak this based on the configuration, based on the requirement that they need. So that is how it is like a proper fit for the data processing, event streaming, and real-time analytics use cases. So that's what summarizes what is Kafka in couple of points. Now let's see its features and what is the advantages in a bullet points. So first one is high throughput. We were just talking about that, how its unique architecture is best fit to handle high volume real-time data feeds. Its distributed architecture allows it to scale horizontally. When we say scale horizontally, that means when you push a message or push event to a Kafka, it is not stored on a single node, on a single machine. It is distributed into multiple machines, so that when one machine goes down, others are ready to serve. So there is no data loss there. And one point is there is no data loss, other is about capacity. So we can add more capacity by adding more nodes, more system into the system. That is how it is very well horizontally scalable. The second point is scalability. So scalability and high throughput goes hand in hand. So scalability we just talked about, like we can just add nodes into the system and it will be good to go. Fault tolerance, it is designed to be fault tolerant and resilient to failures. If something goes wrong with one node, other nodes are ready to serve the producer and consumer's data, because Kafka has two clients only. One is producer, another is client. So one node is down, other node is ready to serve the producer and clients. And data recovery, because the data is redundant, like its copies are stored on the multiple systems. So whenever one node is going down, it is our data is safe with other nodes. So we are good with the fault tolerance part also. Another one is durability. This is the major difference. This is the major feature of Kafka that makes it different from other messaging system like RabbitMQ, ActiveMQ, and others. So whenever you push something, some data on Kafka, it stores that on the disk. So every messaging system stores that on the disk. But the moment any consumer consumes that message, that is lost. But that is not the case with the Kafka. Kafka stores that messages for a particular for a particular time, but that is not unlimited. By default it is like 7 days, but we can tweak it to increase this amount, but that is not good. There is some threshold also, because Kafka is a messaging, because it is there just to pass on the message. It can store the events messages for some moment of time, but we cannot consider it as a persistent system and store the events and messages for unlimited period. Okay, so that's what makes it durable. Any consumers can come any point of time within that threshold, and they will get that message. Another one is stream processing. Kafka provides built-in support for stream processing using the Kafka Streams API, which allows for real-time processing of data stream. So stream processing, the huge amount of data that is generated nowadays, like if you see, there are sensors, IoT devices, set up in like your smart watches, transportation system, medical devices, so which are like sending huge amount of data at every second, and we need the result of that data as soon as possible. So that is where this stream processing comes into picture, and there is like dedicated Kafka Streams API that helps us to get the real-time data processed in least possible time. So it helps that there a lot. So that's what stream processing is very handy with the Kafka. The flexibility that we talked about, like stream processing, data integration, real-time processing, it's about the configuration. It's about the use case that we want to achieve with the Kafka. We can have that configuration only that we talked about. We need high throughput, configure Kafka in that way. We need least latency, we need the data to be processed in least amount of time, configure Kafka in that way. It will work for both the use cases. So it is a lot flexible as per our use cases. And if I talk about another one, like in real time, most of the time we need connection with the databases, like we have MySQL, Oracle, NoSQL databases like DynamoDB, MongoDB. We need connectivity whenever we have case of data migration. We need direct connectivity within that systems also. So with Kafka, there is like concept of connectors and plugins that are available, that we can just configure and it will work if we need to transfer the data from one system to other. And we also need some processing in between that can also happen very quickly and very easily. So that's how it is very flexible as per the use case of the clients. So that's all about the features, and I want to conclude this video with the conclusion that Kafka is a powerful and flexible tool that is well suited for handling large and huge scale of data in a real-time data feeds. So with that, this is the introduction. We understood the capabilities of Kafka, how much it can do. So the next video is about the architecture, where we are going to see how the internal architecture is set up and how we can use it. Okay, so see you in the next one. Thank you for your time. Bye.